Hey everyone, and welcome to The Explainer. Today, we are absolutely demystifying the invisible architecture that essentially runs the modern internet. We're going to break down three really fundamental concepts: proxies, reverse proxies, and load balancers. So if you've ever sat there and wondered what's actually happening behind the scenes of your browser, well, you're exactly in the right place.
I mean, seriously, have you ever wondered how massive apps like Netflix or Amazon survive? They have millions of users streaming and shopping simultaneously, and yet their servers aren't just catching fire. How do they transfer all your data securely, route you to the exact right place, and somehow never seem to crash? Well, the secret lies in these invisible middlemen that manage all the traffic.
So here's our game plan for today. We'll start by defining the core traffic problem, then look at the proxy as your client shield, move on to the reverse proxy acting as a gatekeeper, and then the load balancer as our traffic cop. After that, we'll tie it all together in a real-world cloud architecture and wrap up with a little tech interview prep. Let's dive in.
All right, first things first, the traffic management problem.
To really understand why we need all these complex tools, we kind of have to look at the baseline chaos of direct internet connections. Picture this. You're sitting at your laptop, you're the client, and you type a URL. That request travels across the public, open internet, directly to a web server. The server processes it and sends the website back. Sounds super simple, right? But if millions of people do this directly to one single server, it crashes completely. And if you're doing this on an unsecured network, your private IP address is totally exposed to the world. That's exactly why we bring in intermediaries.
So let's talk about our first intermediary, the proxy, which acts as the client's shield.
Let's see how this thing builds a defense entirely on your side of the connection. A forward proxy, which we usually just call a proxy, is essentially a server sitting directly between you and the internet. So instead of your computer talking directly to the web, you talk to the proxy, and then the proxy talks to the internet on your behalf. Its primary job? To act as your personal shield.
Think of it kind of like having a personal assistant at a restaurant. Let's say you want a reservation, but you definitely do not want to give the restaurant your real phone number because, they're going to spam you with promotional text later. So your assistant calls for you. The restaurant only ever sees your assistant's phone number, not yours. You stay totally anonymous.
So here's how it actually flows. When you request a site, the proxy intercepts it. First, it checks its filters. And by the way, this is exactly how a corporate or school network blocks you from going on social media during work hours. Next, it hides your IP address, giving you anonymity, a lot like a VPN does. Finally, it fetches the website and sends it back to you. And get this, it can even cache or temporarily save that website. So if your coworker asks for the exact same page 5 seconds later, the proxy just delivers it instantly without even reaching back out to the internet. Pretty clever, right?
Okay, moving on to our next concept, the reverse proxy, or the server gatekeeper.
Now, we are shifting our focus completely across the internet. We're leaving the client side and moving over to the server side. If a standard proxy acts on behalf of the client, a reverse proxy acts on behalf of the server. It sits right at the edge of a company's internal network, and it intercepts incoming client requests to protect the really delicate back-end servers hidden behind it.
Let's go back to that restaurant analogy for a second. If the proxy is your assistant, the reverse proxy is the receptionist. When you arrive at a nice restaurant, you don't just wander right into the kitchen and ask the chef for your food, right? You check in at the front desk. The receptionist is the public face of the restaurant. They completely shield the kitchen staff from the chaos of the customers.
And this flow is exactly what heavy-hitter tools like NGINX or Cloudflare are doing all day long. A client sends a request, and the reverse proxy intercepts it right at the network edge. Now, step 3 here is absolutely crucial: SSL termination. Decrypting secure, encrypted traffic is a computationally heavy chore. It takes work. The reverse proxy takes on all that heavy lifting. Plus, it runs security checks against malicious DDoS attacks. This means your back-end servers can focus 100% of their energy on just running the application.
All right, so what happens when things get really busy? Enter the load balancer, our traffic cop.
So what happens when your application becomes so unbelievably popular that one backend server simply isn't enough to handle all the orders the receptionist is passing back? This is where the load balancer shines. Its primary job is horizontal scaling, which really just means adding more machines into the mix and ensuring high availability. It takes a massive stream of incoming traffic and distributes it evenly across a whole pool of backend servers. And the best part? If one server crashes, the load balancer instantly realizes it and stops sending traffic there. To finish out our restaurant analogy, the load balancer is like the maitre d', or a traffic cop at a super busy intersection. They have this bird's eye view of the entire dining room. They know exactly which waiters are totally overwhelmed and which ones are free, and they distribute the incoming guests accordingly, so literally nobody is left waiting too long.
Mechanically, here's how that magic actually happens. A request arrives, and the balancer is constantly performing health checks to make sure the servers are actually alive and kicking. Using algorithms like round robin, which honestly just means it's taking turns sequentially down the line, it forwards the request to the best available server. And it can route this traffic at layer 4, meaning it acts super fast based only on IP addresses, or at layer 7, which means it's making much smarter routing decisions based on the actual application data, like HTTP headers.
Let's pull back the curtain and see how this looks in a real-world cloud architecture.
Now that we have our 3 main puzzle pieces, let's just compare them directly to see how they build on each other. If you look at their placement, a proxy is sitting on the client side, while both the reverse proxy and the load balancer live over on the server side. Their goals are super distinct too. A proxy protects the user's privacy, a reverse proxy protects the server's security, and a load balancer, it ensures scale and uptime.
In reality, any massive site you visit is using all of these at once to create a really robust layered defense. So you make a request. First, it hits a global edge reverse proxy like Cloudflare, which caches static images and immediately blocks hackers. Then it passes through to an AWS Cloud load balancer, which distributes the traffic to different data centers. Inside that data center, an internal reverse proxy, like NGINX, steps in to do intelligent layer 7 routing to send your specific request to the exact right microservice, which then finally queries the database. It's quite a journey.
Now, if you're working in modern cloud environments, like Kubernetes, please don't let the jargon intimidate you. The exact same concepts apply. An ingress controller, it's essentially just a reverse proxy for your cluster. An API gateway? That's really just an advanced reverse proxy managing your microservices. The fundamental concepts of traffic management never really change, Only the tools do.
All right, let's shift gears a bit and get into some tech interview prep.
Here is a classic, somewhat tricky interview question you might actually face if you're aiming for a DevOps role. They might ask, wait, can a reverse proxy also do load balancing? If so, why on earth do companies pay for cloud load balancers like AWS ELB if they already have an NGINX reverse proxy? Take just a second to think about how you'd answer that.
So the answer is yes, absolutely. Software like NGINX or HA Proxy can absolutely act as both a reverse proxy and a load balancer at the exact same time. But industry standard dictates using both cloud load balancers and internal reverse proxies together. Why? Because the cloud load balancer sits on the outside, acting as a kind of dumb but incredibly massive traffic distributor. Meanwhile, inside your private network, your reverse proxy does the highly intelligent, customized routing based on user sessions or cookies. It's really all about combining brute force scale with surgical precision.
Let's quickly wrap this up with the 3 golden rules we've covered. The proxy shields the client, the reverse proxy shields the server, and the load balancer distributes the traffic. Together, they form this invisible, highly complex dance that happens in mere milliseconds every single time you click a link. But it kind of leaves us with a fascinating thought. With all these proxies and balancers sitting in the middle, constantly masking IPs and terminating connections, are any of us ever truly connecting directly to anyone on the internet anymore? Something to think about. Thanks so much for joining this explainer.